In this video, we're going to look at factoring what's called the difference of two perfect squares. Now, the key to doing this is recognizing that you do have the difference of two perfect squares. So the difference of two perfect squares is going to be in this form right here. And this is a little deceiving with the x and the y. X could be anything as long as it's squared, and y could be anything as long as it's squared. Let me give you a couple examples. It's always easier with examples. So let's say, oopsie daisy, let's undo that. Get rid of that. Let's say we have let's say we have x squared minus 9, okay? So here's the checklist. Do we have two terms? Do we have basically a binomial? Yes, we do. We have x squared as a term, and we have 9 as a term. Is each term a perfect square? Yes, it is. All right, this first term is x times x, and this second term is 3 times 3. Is there a minus sign between them? Yes, there is. All right, so we have the difference of two perfect squares. Now, factoring this means that we're going to find two binomials that multiply together to give x squared minus 9. And it's really, really straightforward. All right? So since x squared is a perfect square, whatever goes here and here has to multiply to be x squared. Actually, that's true whenever you're multiplying binomials. So that's going to be x and x. And whatever goes, let's go green. Whatever goes here and here has to multiply to be 9. Well, it could be 1 and 9, or it could be 3 and 3. Now, since this is the difference of squares, it's going to be 3 and 3. And I'll show you why, and maybe we could look at what happens if we use 1 and 9. Now, since we need this to come out to be a negative 9, we're going to have to use one positive and one negative. So basically the answer is x plus 3, x minus 3. Now to check it, all we'd have to do is FOIL this out. So we would go x times x is x squared. X times 3, actually negative 3 would give us minus 3x, or plus a negative 3x if you like. 3 times x is 3x, and positive 3 times negative 3 is negative 9. Now look what happens here. Those x terms drop out. Now that's only going to happen if those x terms are basically the same coefficient with a different sign. That's why if we would have put a 1 and a 9 here to multiply to be 9, we wouldn't get that middle term to drop out. We would have 8x or negative 8x or something like that. All right, let's try another one. Let's get a little bit trickier here. Let's say we've got 4x squared minus 25. All right, do we have two terms? Yes, we do. Is each term a perfect square? Yes, it is. 4x squared is 2x times 2x. 4 is a perfect square. X squared is a perfect square. We have a minus sign. Yep. Oh, and 25 is a perfect square. That's 5 times 5. So now factoring this thing, in other words, figuring out what two binomials multiply together to give this, you have to use whatever times itself is 4x squared. Okay, what times itself is 4x squared? That's going to be 2x and 2x. Don't use 4 and 1 because the middle term won't drop out. I'll show you that up above. 25, we have to use 5 and 5. Now to be a negative 25, we're going to have to use 1 plus and 1 minus. So the key to the middle term dropping out is that these two binomials are the same, except for the sign. That's going to make the middle term drop out. Let's show you. So let's check. Let's check our answer, right? This is our answer. We're done. That's it. That's how easy it is. To check the answer, you could multiply this out and see if you get 4x squared minus 25. All right, so 2x times 2x, that's 4x squared. 2x times minus 5 or negative 5, that's negative 10x. 5 times 2x, that's positive 10x. 5 times negative 5, that's negative 25. See what happened here? That's only going to happen if these two binomials are exactly the same, with the exception of one positive, one negative. So those drop out, and we're left with exactly what we want, As long as this comes out to be what we started with, we know we did it right. Now, if I would have gone, let's put this up here. Oh, is that going to work? There we go. If I would have said, oh, okay, I got 4x squared minus 25. Actually, I should probably do this in red to mean this is wrong. I said, okay, well, what multiplies to be 4x squared? Let's use 4x and 1x. And 25, I'll use 5 and 5. 1 minus 1 plus. So now if we check this by multiplying this out, we would get 4x squared plus 20x minus 5x minus 25. See, that's not going to drop out. It's not going to go away, so that's not right. The only way to make it drop out is to make your two binomials the same, with the exception of 1 plus 1 minus, because you need to get a negative on your last term. Now, before you do one more example, let's say we had something like x squared plus 16. Okay, I'm just going to change it just a tad. So I have two terms, x squared and 16. Each term is a perfect square. X squared, x times x, 16, 4 times 4. But there's no minus sign in there. Now let's see what would happen if we tried to do this. Let's say we do x and x. Okay, let's say we do 4 and 4 to give 16. Now that's a plus 16, so I have to do a positive times a positive or a negative times a negative. Let's say I do a positive times a positive. Let's check it. All right, let's FOIL this out or multiply this out. We get x squared plus 4x. Can you see what's going to happen? Another plus 4x and a 16, which is going to give us x squared plus 8x plus 16. That is not what we started with, so that is not the answer. Well, would it work if we just changed them to minuses? Would that work? Maybe we could just get rid of these pluses. We could change these to a negative and a negative. That'll still give me positive 16, right? So if I checked it, then this would just be a negative 4 and a negative. That's not going to work, is it? Because you'd have negative 8 in the middle. Oh, okay, well, let's see. What if I got rid of one of these minuses and changed it to a plus, like x plus 4x minus 4? Would that give me x squared plus 16? Can you see what's going to happen? Let's see. If I check this, I get x squared. All right, that's a good start. And then I get negative 4x, and then I get plus 4x. That's good. The middle term's going to drop out. But then what? Positive 4 times negative 4 is negative 16. That would give me x squared minus 16. But I wanted x squared plus 16. So there is no way to factor this. This is not factorable. X squared plus 16 is not factorable. So what we say is, we say it's prime. Okay, that would be the answer. That's why we have to have a minus sign in order to factor this thing. If you see a perfect square plus a perfect square, it's prime. It's not going to be able to be factored. Well, let's end with one more example for you to try. Maybe you can try this, pause the video, and then restart the video when you're ready to check it. Let me see if I can trick you a little bit here. Not trick you, but challenge you. That's probably a better word, huh? How about 100 x squared? Oh, that didn't want to work. Let's try that again. X squared minus 49 y squared. All right, give that a try. Pause the video and restart it when you're ready. Okay, so we do have the difference of two perfect squares because we have two terms with a minus between them. And 100x squared is 10x and 10x. 10x times 10x is 100x squared. We need 1 plus and 1 minus. It doesn't matter the order. You could switch that order. 49y is 7y times 7y. And that would be the answer. And that is it. All right, I have to show you one more. This one's kind of fun. Let's say we have x to the 4th minus 1. If you want to give that a try and pause the video, you can do that. All right, x to the fourth is a perfect square because it's x squared times x squared. And 1 is a perfect square because it's 1 times 1, and then we make 1 a plus and 1 a minus. Boom! You're like, why is that so tough? Why did you think that was going to be tricky? Well, the thing is, you're not done yet because the second set of parentheses right here is the difference of squares again. Did you notice that? So we can factor this again. The first set of parentheses, the x squared plus 1, it may not be your first set. You may have written the plus and minus in a different order, but the one that had x squared plus 1, that's not factorable because it has a plus sign. We're done with that factor. But the x squared plus 1 is the difference of squares again. So I could make those two parentheses, the first term x and x, that gives me x squared. 1 times 1 is 1, and then I have a plus and a minus. So these two, x plus 1 and x minus 1, multiply together to give x squared minus 1. Can we break down x minus 1 again? Is this x minus 1 the difference of squares? Maybe this never ends like some kind of eternal factoring problem. Well, there's two terms. Check. Each term is a perfect square. Uh-oh. X is not a perfect square, right? It would have to be x squared to be a perfect square. So it meets 2 out of the 3 criteria, but it doesn't meet the second criteria, so I didn't torture you too much with that. Although if I had started with x to the 8th, then you could do more, or x to the 16th. All right, so that's your answer right there. Now, sometimes you could have a greatest common factor in with these problems as well. Let me just show you one of those, and we'll end with that. Because those get tricky. Students get tricked with those when there's a greatest common factor in there. Sometimes we forget to look for the greatest common factor, and it can sure make your life easier when you find it. So let's say we have something like 3x squared. There we go, 3x squared. Oh, I'll make it a little fun here. How about 12y to the 8th? That's exciting. All right, so you're like, oh, well, there's only 2 terms, so maybe it's the difference of 2 perfect squares, but 3 is not a perfect square, and neither is 12. So you kind of give up. You don't know what to do. You give up on the difference of 2 perfect squares, I mean. But the deal is that 3 and 12 have a common factor of 3. So what if we take that out? Let's see what we have now. We have x squared minus 12 divided by 3 is 4y to the 8th. And lo and behold, now inside the parentheses we have the difference of squares. Because 4 is a perfect square, 2 times 2. X squared is x times x, and y to the 8th is y to the 4th times y to the 4th. Okay, so we break this down. X times x is x squared. 2y to the 4th times 2y to the 4th is 4y to the 8th. We make 1 a plus and 1 a minus, and now it is factored. So look for that greatest common factor, actually not just when you're doing difference of 2 perfect squares, but with any factoring, always look for that greatest common factor first and see if you can take that out, and then proceed with any of the types of factoring you know how to do.